In this video, you're going to learn how to solve linear equations in one variable, and we're going to talk about the different types, like a one-step equations, two-step equations, variables on both sides, multi-step equations, and we're going to go through 12 examples together. There's a worksheet. I have a link in the description below. It's free. You can download that and try these problems on your own if you want to practice or practice along with me. Let's dive into the video. So when you're solving these equations, I like to think of it as three steps, three easy steps. And here's the steps that I go through in my mind. I think about simplifying the left and the right sides of the equation first. Then I try to get the variables and numbers on opposite sides of the equal sign. And then lastly, you always want to solve for just one of the variables, so 1x or 1y or 1z. So let's take a look at this first example. You can think of the equal sign kind of like a dividing line. Some people refer to this as the wall of math. I've heard that said, and I thought that was kind of funny. Basically, you're separating the left side of the equation and the right side. But if you go through these three steps, and these will be more important as we get into the multi-step equations, where there's more than one step, but let's just walk through it. So if you simplify the left side, you say, is there anything that I can do to like combine these together or condense this? Well, not really, because this is a variable and this is a number, and they're unlike terms. When we go to the right side, is there anything we can simplify here? No, that's just a number, 7.1. So then I would go to step number 2. I'd say, well, I want to get the variables and the numbers on opposite sides. So right now I can see that this variable or this unknown quantity x is on the left. So what I want to do is I want to get the numbers on the right side. Now the way that you do that is you do the opposite. So adding and subtracting your opposites, multiplying and dividing our opposites. And so in this case, since we're adding 2.5, let's do the opposite. Let's subtract 2.5 from both sides. It's really like kind of like a teeter-totter. If you've ever done on the playground where you try to balance like the left and right sides, you're trying to keep it equal, try to keep it even, right? So we're going to do the same thing to both sides. You can see that these cancel out because that's just going to be 0. So we're left with x equals, and now we just have to figure out what 7.1 minus 2.5 is. Well, let's see, 1 minus 5, we can't do that, so let's borrow from the 7, that's 6. So this becomes like an 11. 11 minus 5 is 6, and 6 minus 2 is 4. So now we can see that x is equal to 4.6. So with these problems, I try to include some fractions, some decimals, some positive and negative numbers to kind of help you practice those skills as well. And then you can see the last step here is to solve for one of the variable. In this case, we just had 1x, so we're done. So x equals 4.6. Now with equations, the nice thing about algebra is you can check your work. If you take the 4.6, you put it back in for x, 4.6 plus 2.5, yes, it equals the original number, which was 7.1. So you can always check your work. Okay, let's go to example number 2 now. So here we have 2/3 is equal to x minus 1/2. Again, our goal is always to find out what the variable is. That's like our mystery number, our unknown quantity. So again, following these three easy steps, the first step is to just simplify the left and the right sides. So in this case, can we simplify the left side? Not really, it's just a number. Can we simplify the right side? Not really, because we have a variable and a number. We really can't combine those together. They're unlike terms. So step number 2 is to get the variables and the numbers on opposite sides of the equal sign. So in this case, because the variable x is on the right side of the equation, where we'll just draw a line to divide the two sides, we need to get the numbers on the opposite side. So instead of subtracting 1/2, I'm going to do the opposite. I'm going to add 1/2. Whatever I do to the right, I want to do to the left to keep this equation balanced, right? Negative 1/2 plus 1/2 is 0. This just becomes x. And then what's 2/3 plus 1/2? Well, we know when we work with fractions and we're adding or subtracting, we have to have common denominators. It looks like the common denominator here is going to be 6. And sometimes what you might want to do when you're working through these steps here, if you have to do some calculations, it doesn't hurt to like do some of the work on the side and then bring it back into the equation. But it's helpful to keep things lined up, your equal signs lined up, and to be very neat and organized. So we'll go over here to the side. We'll say 2/3 plus 1/2. Looks like they have a common denominator of 6. I just have to multiply this fraction by 2/2 and this fraction by 3/3. This way we get 3/6 plus 4/6, which is going to be equal to 7/6, which is 1 and 1/6 as a mixed number. And then our last step is always to solve for just one of the variable. In this case, we just have 1x by itself, so we're done. X equals 1 and 1/6. Again, if you want to check your work, put that 1 and 1/6 back in for x, subtract a half, and verify that it equals 2/3. If it does, you know you got it right. If it doesn't, you know you're going to have to see where you made your mistake. Okay, let's go ahead and take a look at example number 3. Now, these are just the one-step equations. We're going to get into some more challenging ones, but working with the one step, here we've got 3/5 x equals 15. Now, let's go through the steps. We want to simplify the left and right sides. Well, with these one-step equations, usually there's not much to do as far as the simplifying. You can't do anything on the right. Here, there's nothing we can do on the left. So step number 2, we want to get the variables and the numbers on opposite sides. Well, it looks like we've already got our variables. See, this is 3/5 x, that's on the left. We've got our number here, 15, that's on the right. So we're really down to step number 3, which is to solve for just one of the variable. Here we have 3/5 x, we just want 1x. So how do we get rid of this 3/5? Well, when the two quantities are right next to each other, side by side like that, that means they're multiplied together. So the opposite of multiplying by 3/5 would be to divide both sides by 3/5. Again, remember, whatever you do to the left side, you want to do to the right side to keep the equation balanced. Now, anything divided by itself is 1, so we have 1x. And then remember, when you divide, it's like multiplying by the reciprocal. So it's going to be 15 times the reciprocal of 3/5, which is 5/3. Now remember, any whole number can be written as a fraction by putting it over 1. And then we can multiply across here. This is going to give us, actually, let's just do it right here. So this is going to be 75 over 3, which is equal to 25. And again, notice I like to keep the equal signs lined up to separate the left and right sides. I like to do just one step per line, and then sometimes what I'll even do is draw like a little line in between each of the steps, and then just keep everything organized. Now again, if you want to check your work, if you put 25 back in, 3/5 of 25 is 15, it checks out. Okay, let's look at the last one step type of equation, number 4. And again, let's follow the steps here. We've got simplify the left and right sides. So can we simplify what's here on the left? Not really. There's not much we can do here. Can we simplify what's on the right? No, not really. So step number 2, get the variables and the numbers on opposite sides. Well, you can see we have the variables here on the left. We can see we have the numbers on the right. So that's step 2. And then the last step, you always want to solve for just one of the variable, just 1x. But our question is how can we get rid of this negative 0.2? Well, you see how this is x is divided by negative 0.2? And we know that division and multiplication are opposites of each other, just like adding and subtracting are opposites. So instead of dividing by negative 0.2, let's multiply both sides by negative 0.2. That way, these undo one another, so we're just left with x. But if I multiply the left side by negative 0.2, we need to multiply the right side by negative 0.2. Now, a negative times a negative is a positive, so let's just write a plus sign or a positive there. And then when we multiply, 2 times 6 is 12, 2 times 2 is 4, plus 1 is 5, and then we've moved the decimal place once, twice, so I'm going to move it once, twice. So you can see x is coming out to positive 0.52, and you got it. Now, again, if you want to check your work, you take that 0.52 and you put it back in. 0.52 divided by negative 0.2 gives you negative 2.6, so you can verify. Well, let's take a look at the two-step equations next. Okay, for number 5 now we have 2x minus 3 equals 11, a two-step equation. But I always like to think of these 3 steps just to keep it real simple. So first step, can we simplify the left side and can we simplify the right side? Meaning, can we combine like terms or condense this in any fashion? Well, in this case, we really can't. This is a variable, this is a number, we can't combine them. And this is just a number here, we can't simplify that right side. So step number 2, we want to get the variables and the numbers on opposite sides of this equal sign. So here I can see that I have the variables on the left side. So that means I want to get the numbers on the right side. But to get the numbers on the right side, that's like saying I have to get rid of them on the left. How do we get rid of something? We do the opposite. So instead of subtracting 3, I'm going to add 3 to both sides. and then we just add these two lines together. So 11 plus 3 is 14. Carry our equal sign down. Negative 3 plus 3 is 0, and 2x. Okay, now we're down to step number 3, which is to solve for just one of the variable. Here you can see we have 2x. And again, notice the 2 and the x are side by side next to each other. That means they're multiplied together. So the opposite of multiplying by 2 is to divide by 2. Whatever we do to the left, you want to do to the right. 2 divided by 2 is 1, so we get 1x is equal to 14 divided by 2, which is 7. And you got it. Now, if you want to check your work, you go back to the original. 2 times 7 is 14, minus 3 equals 11. So it makes the equation true, so we know we've got the correct answer. Okay, let's take a look at number 6 now. Same idea, we want to simplify the left and right sides if possible. So in this case, we really can't combine the 1/2 x and the 2, because that's a variable, that's a number. They're unlike terms. Negative 4, that's just a number. We can't simplify that with anything on the left side here. So step number 2, how do we get the variables and the numbers on opposite sides? Well, we can see here that we have the variables on the right. See, the x, the unknown, is on the right, which means we want to get the numbers on the left. To get the numbers on the left, that's like saying we have to get rid of them on the right by doing the opposite. Instead of adding 2, we're going to subtract 2 from both sides. 2 minus 2 is 0. Bring our equal sign down. 1/2 x. And then negative 4 minus 2 is negative 6. So if you need to review your positive and negative numbers, you can check out some of my videos on mastering negative numbers. Okay, so now we're down to step number 3, which is to solve for just one of the variable. We've got 1/2 times x, but we just want 1x. So what's the opposite of multiplying by a half? Dividing by a half, right? Now, sometimes when I have fractions, instead of dividing, what I'll do is I'll just multiply by the reciprocal. So I'll multiply by 2 over 1. This way, you can see these cancel, and that just gives us the variable x by itself. If we multiply by 2 on the right, we want to multiply by 2 on the left. And 2 times negative 6 is negative 12. And that's our final answer. We solve for just one of the variable. Now again, if you want to check your work, you put it back in. 1/2 times negative 12 is negative 6. Negative 6 plus 2 is negative 4. It checks out. Let's talk about when you have variables on both sides of the equation, the left and the right. Let's do that next. Number 7 now, we've got variables on the left, variables on the right. So a little bit more challenging, but we're still going to follow these 3 easy steps. So first step, can we simplify the left side, and can we simplify the right side? Well, it looks like we have a variable and a number. We can't combine those. On the right side, variable and number, we can't combine those. So step 1, there's nothing we can really do. But step 2 now, we're going to get the variables and numbers on opposite sides of the equation. Now, it doesn't matter whether you get the variables on the left and the numbers on the right, or vice versa. It's up to you. Sometimes one way might seem a little bit easier than another, but you're going to get the same answer in the end. So in this case, I'm just going to get the variables on the left side. To get the variables on the left side, that means I have to get rid of them on the right side. How do you get rid of something? By doing the opposite. This is like a positive 3x, which is a plus, like addition, okay, plus 3x. So we're going to do the opposite. We're going to subtract 3x. If I subtract 3x from the right side, I have to subtract 3x from the left side. So now 7x minus 3x is 4x. I'm going to bring down the minus 2. Keep our equal signs lined up. 3x minus 3x is 0. And I'm going to bring down the 10. Okay, now we've got the variables on the left. We want to get the numbers on the right. How do we get the numbers on the right? We have to get rid of them on the left by doing the opposite. Instead of subtracting 2, we're going to add 2. And we want to do it to both sides to keep it balanced. Negative 2 plus 2 is 0. Let's bring down the 4x. Keep our equal signs lined up. 10 plus 2 is 12. So now you can see we've accomplished getting the variables and the numbers on opposite sides. We want to solve for just one of the variable for our last step. We've got 4x, we just want 1x. You can see they're next to each other. That means that they're multiplied together. So instead of multiplying by 4, let's divide both sides by 4. 4 divided by 4 is 1, so we get x is equal to 12 divided by 4, which is 3. And you got it. Now if you want to check your work, you take the 3, you put it back in for this x, and you simplify, make sure the left and the right sides, they match. For number 8, another equation where we have variables and numbers on both sides. So we're going to go through the 3 steps. Simplify the left side and the right side if possible. So here on the left side, I can see that I've got a positive 3 and a positive 8. I can add those together. So 3 plus 8 is going to give us 11, or positive 11, or plus 11. And here we really can't combine anything because we just have a variable and a number, and they're just added together. They're unlike terms. So that's step number 1. Step number 2, get the variables and the numbers on opposite sides. It doesn't matter which side you pick. In this problem, we got the variables on the left. So how about on this problem, we get the variables on the right, just for variety. So if I want to get the variables on the right, I have to get rid of them on the left by doing the opposite. So I'm going to add 4x to both sides. Negative 4x plus 4x is 0. I'm going to bring down the 11. Negative 6x plus 4x is negative 2x. I'm going to bring down the 10. Okay, now we have the variables on the right, which means we want to get the numbers on the left. How do we get the numbers on the left? We have to get rid of them on the right by doing the opposite. I'm going to subtract 10 from both sides. That gives us 0 here. This is negative 2x, and 11 minus 10 is 1. Last step, we want to solve for just one of the variable. We have a negative 2x, we just want 1x. What's the opposite of multiplying by negative 2? Dividing by negative 2. And so now you can see this is 1x equals negative 1/2. And that's our final answer. We solve for one of the variable. Now you can put this back in for x wherever you see x and simplify the left side and right side, make sure that they match, and verify. Now you might be saying right here, I'm thinking out loud, negative 2x. Some students might think, well, isn't this subtracting 2? Shouldn't I be adding 2? But remember, when they're right next to each other like that, it's understood to be multiplication. So instead of multiplying, we're going to divide. Let's take a look at the multi-step equations now. For number 9, we've got this equation, which looks a little bit more complicated than what we've been working with. So let's follow the 3 steps. First, starting with simplifying the left side as much as you can and the right side as much as you can. So here you can see that we have this 5 on the outside of the parentheses. And when you have that 5 right next to the parentheses like that, what we do is the distributive property, which means that you're multiplying the 5 into the parentheses. So 5 times x is 5x. 5 times negative 3 is negative 15. And then we have this minus 2 here. Same thing on the right side. That 2 is right next to the parentheses. We're going to multiply or distribute into the parentheses. 2 times x is 2x. 2 times 1 is positive 2. And then now we're still on step 1. We're still in the process of simplifying the left side and the right side as much as we can. And I can see that we can combine the negative 15 and the negative 2. That's going to give us negative 17. And here we can combine the 2 minus 4, which is just negative 2. So sometimes, even though it's 3 easy steps, you might spend a couple of lines, or a couple of, processes to complete that first step here, okay? So step number 2 now, we want to get the variables and the numbers on opposite sides. Now, sometimes students like to set it up in such a way that they don't have any negative variables like that. And so they might say, well, I'm going to try to get the variables here because I can see that's going to work out to a positive number. But it really doesn't matter. As long as you get the numbers on one side, variables on the opposite side. So I'm going to get the variables on the left by getting rid of them on the right. So I'm going to subtract 2x from both sides. I like to draw a line like that, and I think about just kind of adding straight down. So 5x plus negative 2x is equal to 3x. Bring down the negative 17. 2x minus 2x is 0. Bring down the negative 2. Okay, we've got our variables on the left. We want to get our numbers on the right. How do we get them on the right? We have to get rid of them on the left by doing the opposite. Instead of minusing 17, we're going to add 17. That cancels out. We're left with just 3x, and negative 2 plus 17 is 15. Now we've completed our getting the variables on the left, numbers on the right. We're on step 3, solving for just one of the variable. Here we have 3x. We just want 1x. Instead of multiplying by 3, let's divide both sides by 3. 3 divided by 3 is 1, and you can see we're getting x equals 15 divided by 3, which is 5. And you got it. Now again, if you want to take some time and go back and put 5 in here, wherever you see x, simplify both sides, make sure that the left side and the right sides match, and verify you got the right answer. Okay, for number 10, same idea. Got a lot going on here, But if we follow these 3 steps, we're going to get to what x equals. Now, sometimes students say, well, couldn't I just maybe try plugging in some numbers like 1 or 2 and see if it matches? See, that would take a long time. You might be able to do that on like the 1-step equations and maybe even the 2-step equations, but it's hard to guess what x is on these multi-step. So that's why we like to follow this process. So let's simplify the left side as much as we can. We're going to distribute the 1/2 into the parentheses. That's going to give us 1/2 times 6x, which is 3x. 1/2 times -12 is -6. Over here we've got 2x plus 1x is 3x, and I'm going to bring down the -4. Now we want to get variables and numbers on opposite sides. So that's step number 2. So I'm going to get the variables on the left. So I'm going to subtract them on the right. So -3x minus 3x. Okay, that cancels. That cancels. Look what we're left with. -6 is equal to -4, which doesn't really make any sense, right? How could -6 equal -4? They're 2 different numbers. So what that tells you, when the variable cancels out like that and you're left with something that's doesn't make any sense, they call it like a nonsensical answer, that tells you that there's actually no solution to this equation, meaning no matter what you put in for x, the left side and the right side will never match. So this is kind of like a special case, but is important to recognize. Let's take a look at 2 more multi-step examples. If you've made it this far in the video, you probably like the way that I explain things. And if you're learning about algebra and you want to go deeper with me, I've got an Algebra 1 course for sale and an Algebra 2/College Algebra video course for sale. And I've got links in the description below. So check out those video courses. They each consist of like about 85 and the other one has 87 lessons. And I take you step by step, you know, each lesson building on the previous lesson. We go through the concepts, we go through example problems. I give you some problems you can practice on your own and we go through those as well. So the courses are very detailed, and if you like the way I explain things, check those out. But for number 11, let's continue on with this. I try to make each problem a little bit different than the previous problems because I want you to kind of learn as much as you can, as quickly as you can, but I also have to try to include the different types so you can kind of see what things that you're going to encounter. So let's look at 11 and 12, and then that'll wrap up this lesson. But here we've got 4x and -1x. That adds up to 3x, and I'm going to bring down that -5. Over here on the right side, we're going to do that distributive property again. That's 3x plus 6, bring down the -11. Now we're still on the first step of simplifying the left side and the right side. I can see that I can combine the 6 and the -11. That's going to be -5. And here we've got 3x minus 5. Now you might notice at this step, you know, say Mario, I can see that the left side and the right side are equal. What does that mean? Well, they call that an identity, like the left side is identical to the right side. And when you have that, it tells you that there's going to be infinitely many solutions because whatever you put in for x, the left side and the right side are going to be the same. But say you don't notice that and you say, well, I'm going to subtract 3x from both sides of the equation. And then you end up with something like -5 equals -5. You notice your variable's gone, but what you're left with is exactly the same. So that's another way to recognize that it's an identity, or you could say infinitely many solutions, or all real numbers. Okay, in the last example, number 12, if you're getting the hang of this, see if you can pause the video and try this one on your own. This one I'm going to distribute first, so -14x plus 7. We're still on the first step. We want to combine like terms. -14x plus 1x is -13x plus 7. Okay, now here what I'm going to do, I'm going to get the variables on the right by getting rid of them on the left. So I'm going to do the opposite. I'm going to add 13x to both sides. So that cancels. We've got 7 is equal to 21x minus 2. Got the variables on the right, which means we want to get the numbers on the left. So we'll do the opposite. We're going to add 2 to both sides. So these cancel. We get 21x is equal to 9. And we want to just solve for one of the variables. So we're going to divide both sides by 21. And with fractions, you always want to reduce to lowest terms. I can see that 3 goes into both of these. 3 goes into 9 3 times. 3 goes into 21 7 times. So our answer is x equals 3/7. Again, you can plug it back in and verify that the left side and the right side match. And this is a good answer. So If you like this video but you want some more practice learning about how to solve one variable equations, whether it's one step, two step, multi-step, variables on both sides, follow me over to that previous video I did right there to get some more practice. I'll see you over in that video.